I'm François Couny from EXFO. Actually, even it's experts in fiber optics. So we're a test and measurement company for anything to do with fiber optics, portable, but also in R&D and development of new optical components. I would say not limited to telecoms, but mostly within the telecoms wavelength range. And today, it's my pleasure to introduce a new product family of tunable lasers. So tunable lasers are at the heart of most of our systems for testing optical components, providing the wavelengths variation, and we interrogate the spectrum of the component and reconstruct basically this information, this response of the device with this type of lasers. So what we are looking for in this type of equipment is obviously a broad wavelengths coverage. And we have with the T200S and the T500S here some tunability within the O band or the CL band, so around 1310 or 1550 nanometers. But with the T500S, we go even further and we cover the in-between bands, so the O band or the CL band, but also the bands around 1400 or 1500 or even all the way up to 1680 nanometers. You're looking also for a laser with high power, typically 10 dBm, but even much higher than that, 15 or so. You're also looking for a laser, if you want to interrogate correctly your component, a laser that has a low noise and a usable signal that is quite high. So here we're referencing the signal to source spontaneous emission ratio, SSSER, and needs to be as low as possible. And also we need to be able to scan or to perform a sweep of the wavelengths on these devices as quickly as possible. Here with these new lasers, we introduce at 200 nanometers per second. Previous line of lasers that we had that was at 100 nanometers per second scan. And during that sweep, during that movement of the wavelengths, you also want to avoid mod hops. So you want to have a continuous, smooth variation of the wavelengths as you do so. So going into more details about the two lines of products, the T200S CL and T200S O band. So cover as the name implies, the O band or the CL band. So you can see at the bottom here, there's a wavelength range that is covered with an optical power output of 10 dBm. And with a sweep speed of 200 nanometers per second scan. So during that sweep speed, which basically would only take a half a second or so over this range, you can then collect some data, some acquisition about the component that you're testing. This is made possible with the two component testing products that we have at EXFO, the CTP10 and the CT440, which are the two products that collect the data and display the spectrum automatically on the screen using such tunable lasers. What is also interesting with this laser is that it can be used as a fixed wavelength or go-to wavelength within the range of the wavelength that's possible to cover, with a line width that is below 50 kilohertz, and with an accuracy of plus or minus 5 picometers. So this is a very good go-to wavelength laser with that is actually very narrow in terms of line width. So it could be useful both for an application where you want to go to a wavelength, perform a measurement, an alignment of some kind, and then perform a sweep within the same wavelength range. So for peak application, photonic integrated circuit application, for example, this is quite interesting to align first at a fixed wavelength and then perform the scan. Going further with the T500S, so this covers a much broader wavelength range through different models that are listed below, with three models: the O band, the ES band, and the CLU band. We can cover with three lasers from 1240 nanometers to 1680 nanometers. with an adjustable optical power that is 10 dBm but above, with a peak of 14 dBm. And here the strength of this laser is also the fact that it is usable in both directions of the sweep. So you can sweep from low wavelengths to high wavelengths. And when you come back to the low wavelengths, it is also calibrated and functional so that it can be used, or will be able to use it, with the CTP10, once again, the component testing platform from EXFO. This is an upcoming function, but we're developing right now this functionality so that you can gain in terms of speed, and speed we know is essential for photonic integrated circuits. So positioning these two new tunable lasers, continuously tunable lasers, within the range of the EXFO's portfolio of tunables, we have the micro ITLAs starting at the bottom here. So they are mostly a go-to laser, and you fix the wavelengths and you kind of leave it there in the C or the L band through two products. So stepped tunable laser through the T100 that is available, as you can see, in a mainframe that's called the O6 platform. Here we have several wavelengths range that are covered, and each of them are stepped tunable, which means that they're not usable when they change the wavelengths. To be able to do that, you need a continuously tunable laser, and this is where these two lines of two families of products, the T200S and the T500S, come into play. And we can clearly see here for the T500S, the O band, the S band, and CLU band, with some overlap in between all of them. With 3 lasers, we can cover the full wavelength range. So that could be interesting. Once again, coming back to a spectral characterization, where you sweep the laser or the lasers as a function of wavelengths, and with the CTP10, which you can see here in the middle, you can collect this information regarding wavelengths, the information on the power through the bank of detectors that are inside this instrument. And then you can recreate the actual performance or the spectrum of the filters, the ring resonators, the AWGs that you are actually measuring. You do that with picometer resolution at speed, 200 nanometers per second bidirectional. And you can even have further measurements, such as polarization dependent loss. You can test up to 100 outputs from one single device. And obviously, here I'm talking about telecoms wavelength range, spectral testing. So once again, within the range of each of the laser or lasers, if they are combined together. So here today, we've introduced the swept tunable lasers. They're part of a larger portfolio of products when we talk about peak testing or photonic integrated testing. It being a simple laser and detector on the left-hand side, matrix switch, an optical spectrum analyzer also with the OCA20 that can be useful to test lasers or WDM signals. And to the right-hand side also, it's interesting sometimes to go further with the testing of such components and test the traffic analysis. This is more for transceivers and mainly telecoms applications, but this is something that is possible within the portfolio of EXFO. So on that note, I will end. And if you want more information, just type in within the EXFO website, a tunable laser or lasers, and then you'll have more information about the family of products and these 2 products in particular that we've launched today. Thank you very much.